Welcome to Ask and Learn.
No, the laser light passes through a small opening to enter the tube. Therefore, it diffracts and spreads out as it moves through the tube. So it will not be parallel. But at very small distances, it will be parallel. In part B of this problem, we are going to calculate the divergence angle of the beam, that is theta 1. In order to calculate this angle, let's write the formula. Theta 1 equals to 1.22 lambda divided by d, where this d is the diameter of the aperture. Now by inserting values into this equation, we can write theta 1 equals to 1.22 into, we have the value for lambda as 633 multiplied by 10 raised power minus 9 meter divided by value for d is 1 multiplied by 10 raised power minus 3 meter. So this will give us the value for theta 1 as theta 1 equals to 7.723 multiplied by 10 raised power minus 4 radian. Or it can be written in terms of a degree as theta 1 equals to 7.723 multiplied by a radian multiplied by radians multiplied by 180 degree divided by pi radian. So this will give us the value for theta 1 as theta 1 equals to 0.044 degree. So this is the answer of second part of this problem. Now in part C of this problem, we are going to calculate the diameter of the beam, that is omega. Now in order to calculate this diameter, let's write the formula for the width of the central maximum, that is equals to the diameter of the beam. So we can write omega equals to 2.44 lambda L divided by d. Now by inserting values into this equation, we can write omega equals to 2.44 into, we have the value for lambda as 633 multiplied by 10 raised power minus 9 meter, and the L has the value of 3 meter divided by d, which has the value of 1 multiplied by 10 raised power minus 3 meter. So this will give us the value for this omega as omega equals to 0.463 multiplied by 10 raised power minus 2 meter. It can be written as omega equals to 0.46 centimeter. So this is the answer of part C of this problem. Well, in part D of this problem, we are going to calculate the diameter of the beam after it travels 1 kilometer of distance. So let this diameter is omega prime. In order to calculate this omega prime, we use the equation as omega prime equals to 2.44 lambda L prime divided by d. Now by inserting values into this equation, we can write omega prime equals to 2.44 into, we have the value for lambda as 633 multiplied by 10 raised power minus 9 meter into 1 multiplied by 1.0 multiplied by 10 raised power 3 meter divided by d, which has the value of 1 multiplied by 10 raised power minus 3 meter. So this will give us the value for this omega prime as omega prime equals to 1.54 meter. So this is the answer. End of the question. Thank you.